397 integer replacement. So for this problem, we are given a positive integer n, and we can apply one of the operations. So if n is even, we're gonna replace n with n divided by 2. If n is odd, we're gonna replace with either n plus 1 or n minus 1. So we're gonna return the minimum number of operations needed for n to become 1. So for this problem, I think the easiest way is gonna be BFS. But before we are using BFS, we need to analyze why we can use it. So basically, why we are using BFS, the time complexity is gonna be log n. So instead of O(n). If it is O(n), it didn't work because n gonna be 2 to the power of 32. Yeah. So why it is log n time? Because, so for example, if n is a really big number, so for example 10 to the power of 9, yeah. So because this is an even number, so it's gonna become half of it, yeah. So maybe this n gonna become 10 to the power of 9 plus 1. It is even or odd. It's gonna first of all, it's gonna plus 1 or minus 1, and then it's gonna divide it by 2. But no matter which way, this kind of operation, we don't have so many this kind of operations. But how many this kind of operations, it's going to be log n time. And how many this kind of operations, it's also log n time. It means 2 times log n. So it is still log n time complexity. So this is why we can use it. Yeah, even though we have this kind of operation, but only if it is odd, and then we're going to use either this one or this one. Yeah, but definitely not every time. So this is why. So if we don't have this kind of operation, definitely that's going to be, the time complexity going to be really big. But luckily for us, we have this kind of operation n divided by 2 while it is even, and n plus 1, n minus 1 while it is odd. So this makes the time complexity becomes log n. So this is why we can use BFS directly. So let me just prepare a queue as the queue, and I'm going to put the integer inside. And I don't need to prepare a weighted set because the time complexity is just log n. We don't need to do that. Yeah. Now, let me put a tuple inside. It's going to be this number and how many steps. So from the beginning, it's going to be 0. So while queue, I'm going to pop out the current number and the step from the queue. So I need to always use the queue.pop left. Otherwise, you're going to make a mistake. If you use queue.pop, definitely it is not okay. Yeah. Now, what we're going to do, if current equal to 1, we're going to return the step immediately. If current modular 2, so this means it is an odd number. So if it is odd number, we're going to append, yeah, with n plus 1, step plus 1, and similarly, we can append n minus, yeah, it is not n, it is current, right? So it is current plus 1, and current minus 1, and step plus 1, yeah. So else, if it is even, so we need to append current divided by 2 with the step plus 1. So this is going to be the entire code. As you can see, it is just a very basic BFS, but we need to analyze the time complexity first. So this is going to be step. Now as you can see, it works. Now let me submit it. Yeah, so as you can see, it works, and it's pretty fast. Yeah, because the time complexity is going to be log n. Yeah, so for analyzing this problem, so this is a tree structure. But for each of the time, so maybe this is a even number, so it's going to become this. It's going to become this number. Or maybe this time it is odd. Yeah. If it is odd, what are we going to do? Yeah, we're going to have 2 directions like that. Now, yeah, so if it is, so for example, this is even, right? This is even, and after even, this is odd. Oh, it has 2 directions. Yeah. Now this is even and this is even. It's gonna be like this. Yeah. Yeah, because this is even and divided by 2, it may be odd. If it is odd, it may be like this. But if it isn't even, it is like that. Yeah. But basically, basically, the time complexity is log n. So instead of O(n). Yeah, because the tree is not become wider and wider. It is just like that. Yeah. So for example, this is even. So for example, this is 1000. This is even. Yeah. And this is 50. It is still even, right? And we're gonna continue. And yeah, let me make the drawing better maybe. So if we have a number 100, what's gonna happen? So first of all, this is 100, and then it is 50, and then it is 25, and if it is 25, it's gonna become other 2, so it's gonna become 26 and 24. Yeah. Now this 24. Yeah, let's just analyze 24. So this 24 gonna become 12, and this 12 gonna become 6, and this 6 gonna become 3. Yeah, because it is even and divided by 2, and then it becomes 2 and 4. So this 2 becomes 1, and this 4 becomes 2, and 2 becomes 1. Yeah. So as you can see, this is not becoming wider and wider. So it is some at some positions it may have 2 branches. Yeah, so in this example it is 26. So for this 26, here it will become 13, and after this 13, it may become wider. So it become 14 and 12. Yeah. So for this 14 and 12, the 12 will be like this, and the 14 will continue like 7 and become wider. Yeah, but as you can see, the whole process it didn't become wider and wider. So this is why the time complexity is only log n time, and this is also why we can solve it in this way. Yeah, because if it is even, if it is odd, we can directly make it even, and we can directly reduce it. Yeah, reduce it by half. I think that's all about it. Thank you for watching. See you next time.